This is your gentle introduction to GitHub Actions. Hello, my name is Janne and welcome to another video. This time we are talking about GitHub Actions and how you can get started with your own workflows. I will start this video with an introduction to Actions, and in the second part we will go through some practical examples. The code that I'm using in this video is available in my Actions Playground repository that is linked down in the description. If you'd like to see some new workflow added to the repository, you can submit an issue or even a pull request, and maybe we'll see that in a future video. But now, let's get started. So what are actions? They are a way to run code on your repositories. So you can create custom workflows that automate things on your repository. Actions can be triggered on different kinds of events. For example, push, pull request, when a new issue is added, when a new comment is added, or on schedule, and more. There are runners for Linux, macOS, and Windows. So no matter what platform you are targeting, there should be a runner for you. Best of all, using Actions is free for public repositories, and you get 2000 minutes per month for your private repositories. Notice that using Windows or macOS runners will use up your quota at a faster rate than the Ubuntu one. Actions are configured with YAML files that are stored in GitHub Workflows directory inside your repository. And that's the place where GitHub automatically finds them and starts to execute them. Let's get to the syntax. Here we go through the three most common parts of an action file. So the first one is the action name. It's defined with the name parameter. And it can be anything. For example, CI or unit tests or lint or whatever you come up with. This is only shown in the web UI, so you can really choose whatever you want. Next, there are the triggering events. And here I have listed some examples. They are always defined with the on keyword, and then you can have different rules. For example, with this configuration, the action will trigger on push events to master and develop branches only. And here, only pushes that would contain changes to Python files would trigger the action. You can also trigger on push to tags. For example, this one would trigger on any tag that starts with v1. Notice that you can also omit parts of these configurations. So you could, for example, have only on push, in which case all push events would trigger the action. There are also other types of triggers, such as the issue trigger. This one, for example, triggers when an issue is opened or closed. You can also react to issue comments, pull request reviews, and new releases. You should check the full list of available event triggers from the GitHub Actions documentation. You can also run the actions on schedule. So in this case, the action would run every Monday midnight UTC time. The third required part of a workflow is the jobs definition. It contains the main logic for the workflow. There you can define one or more jobs that can run in parallel. The runs on keyword defines which runner type should be used. And as I mentioned, the available options are Ubuntu, Windows and macOS. The actual workflow logic is contained in the steps section. There you can call actions made by other users, or you can run command line commands. And by combining multiple actions you can create quite complex logic. Here is an example jobs definition that you get when you create a new workflow on the GitHub repository. This one contains one job. It's called build. It runs on the Ubuntu latest runner and it has 3 steps. The first step uses an external action, which is the actions checkout version 2. This action clones the repository to the runner, so it is one of the most used actions. The next 2 items are examples for running command line commands. As you have a full-blown virtual machine at your fingertips, you can use the run keyword to run whatever command you wish. This opens up lots of possibilities for your workflows. You should also check the GitHub Actions documentation, which contains lots of useful information to get started with using actions. So whenever you have a problem, that's the place that you should check first. Next, let's see some practical examples. Now that you know how actions work, it's time to look at some practical examples. I have initialized this GitHub repository beforehand, and I have also cloned it to my own computer, so I can start working with it right away. The first action that we are going to take a look at is the Actions labeler action from the official GitHub Actions repository. With this action, you can automatically label pull requests based on the changed files. So the first thing that we need to do is to create this configuration file. So let's go back to our repository and click Add File, Create New File. And the configuration file needs to be in the .github folder with the name labeler.yml. I have already created a configuration file to make this faster, so I'm going to paste it in here. So this file follows the YAML format, which is the same as you have with GitHub Actions. So for each entry, we have the label first, and then we have a list of matchers to select which files apply to which label. So for example, this configuration reacts to all Python files and gives the label Python. Notice that emoji are also supported, so you can spice up your labels. Here all markdown files will be labeled as documentation. If you would have a Docker file, then it would get the Docker label, and anything in the .github directory will get the CI label, which stands for continuous integration. Let's commit this to a new branch. I will call this labeler. I don't want to open a pull request quite yet. Let's check the labeler branch. Now that we have the configuration, we need to configure the workflow. You can get the example workflow from the Actions labeler repo. I'm using a slightly modified version with a different name. Now let's switch to the labeler branch and create a new file. This will be the workflow file, so it will be located in the .github workflows, and I'm going to name this file prlabels.yml. The name of this action is going to be prlabeler. It's triggered on the pull request event. Then in the jobs definition, I'm going to name this job label. And now we need to set the runner environment. So we use the runs on and choose Ubuntu latest. Next we have the steps. We have only one step. We use the uses keyword. We are using actions labeler at version 2. And the parameters are defined with width. And this action needs the repository token with the repo token input. And here we can use the default token given by GitHub. So it's located in secrets.github token. Let's commit that to the labeler branch. Next, let's open the pull request and see what happens. Now GitHub noticed that there is an action that it can run. And as you can see, the CI label that we configured was automatically added because we edited content in the .github directory. Now that that action works, we can continue on to the next one. Let's just merge this pull request and delete the branch. As the next example, we are going to create a bot that greets first-time contributors or issue openers. This can be done with the first interaction action. This is also a really simple action to set up. As you can see from the README file, you only need to use the first interaction action and give it the repository token and the issue message and pull request message that you want to be displayed on the PR or the issue. These parameters are not required, and if you omit, for example, the issue message, the bot will not post any messages there. So you can configure actions also on this Actions tab. You can click New Workflow and set up a workflow yourself. I'm going to call this workflow First Interaction. We need to change when this action triggers, so remove the existing ones and configure to trigger on issues with types opened, and that's it. Next, configure the jobs. I'm going to call this interaction. Keep the default runner and remove the existing steps. Then just define the action, which is actions first interaction at version 1. And next we need to set the parameters. I'm going to copy this over from elsewhere. Let's paste that in. So here I have the repository token, which is the required parameter. Then we have the issue message, which I have defined as a multi-line string using this pipe character on the first line. And this message supports Markdown, so you can include links like this, for example. Now we are ready to commit this to the repository. Again, I will create a new branch, which I will call first interaction. Propose a new file and create a pull request. This should also trigger the PR labeler, and we should see the CI label assigned to this PR. It took a few moments to run, but now we have the PR labeled correctly. So let's just merge the pull request again. Now to try this actually out, I'm going to use my machine account. Let's open a new issue. If we go to the Actions tab, we can see that the first interaction was running. And the GitHub Actions bot has commented on the issue with a link to the wiki page, which actually doesn't exist in this repository. But that clearly works. So let's close this window and continue. Let's add another workflow. So add a new workflow and set up it yourself. This time we are going to set up the actions tail action. So let's take a look at it. This action closes tail issues and pull requests. And you get the full example from the README file. So you can basically just copy the version that you want to use and replace the contents of the file with that one. So let's see what we have here. The name of this workflow is close tail issues. It triggers on schedule with a cron job that runs at midnight UTC every day. It uses the Ubuntu latest runner and the Actions stale version 3 action. Then the message that you want to use for stale issues and the configuration for how many days to wait before marking the issue as stale, and after marking how many days should be waited to close the issue. If you check the action.yml file, you can see all the inputs for this action. So in addition to the ones that we have copied over, you can set many other parameters. For example, you can configure which label should be applied when a pull request is marked as stale, or the same for issues. And you can also limit the check to pull requests and issues that match a certain label. Let's remember to change the name of this file, so I'm going to call this stale.yml. This time I'm going to commit this directly to the master branch, because we have already tested that the labeler bot works. Now this issue here should be marked stale 30 days from now, and after 5 days of inactivity it will be automatically closed. Unless someone comes here and writes a comment, which will reset the timer. Alright, let's move on. The next thing that you can configure is an automatic style checker for the code in your repository. I'm going to use Python as the example language here, so I'm going to configure 2 different checks for Python code. But there are many similar checks available for other languages too, such as JavaScript, Go, Java, and so on. So this is just an example for one language. The first check that I'm going to set up is the black code formatter. Black is touted as the uncompromising code formatter, which takes your code and transforms it to an opinionated standard. This way, you don't have to think about the formatting, because Black will take care of that. But if we want to accept pull requests from other developers, we will need to make sure that the code that they submit is formatted properly. In the GitHub repository of Black, there is actually an example workflow, but let's write that from the ground up. Let's set up a workflow, and let's remove everything. Again, we start with the name, and this is simply Black. Then trigger with trigger on pull requests. The example here triggers also on push, but then it will trigger twice for pull requests. You can pretty much choose either one. Next, define the jobs. This job is called Black. And it runs on Ubuntu latest. Next, the steps. This uses first the actions check out at version 2, which checks out your repository. Then it uses the actions setup Python, and then we run psf black at stable. Right now, as I'm recording this video, the stable version actually doesn't work, so I need to change this to the master version. Let's start the commit and create a new branch called Black and propose the new file. As you can see, I actually forgot to change the name of the file, but we can fix that later. Let's create the pull request in the meanwhile. So let's switch to the GitHub desktop here for a moment. I'm going to check out this branch that we just created. And let's open this on Visual Studio Code. So this was the action that we just created. Let's rename the file and just call it black. Now, black doesn't really require any configuration, but you can configure it with a pyproject.toml file. And here is an example file from the repository readme file. I like to use a line length of 100 in my Python code. So we can copy these lines here and create the configuration file. And just change the line length to 100. Now we of course need some Python code to test our action. So let's create a new folder called project. This is just a dummy project. So I'm going to create a new file called sample.py. And there is an easy way to make the black check fail. Black likes to use double quotes for strings, unless using single quotes reduces the amount of escaping needed. So let's just put hello world in single quotes. And this should now fail the check. Let's go actually back to the pull request and see the existing checks. So you can see that GitHub has run black against this PR already, and it was successful. If you go to the details, we can see the steps that the workflow has taken. And expanding this black run, we can see that no Python files were present to be formatted, and black had nothing to do, which we were expecting. Now let's just commit this file to the repository, along with all the other changes. So let's say add project. Add project sample file. And then push to origin. Now we have a new check. The labeler bot noticed that now there is a Python file present in this pull request, and it added the Python label automatically. And now the check has failed. Let's go to the details. If you open the black section, we see that one file would be reformatted. So this print with single quotes would be changed to print with double quotes. Notice how this action doesn't actually reformat the file. That would be a nice feature to have, but if you're getting pull requests from a forked repository, then GitHub Actions doesn't have write access to either one of them. So this action wouldn't be able to commit the changes. Let's change these to the double quotes to fix the error. We could also have just run black against this code, but this is faster for now. Let's get back to the pull request. It took a while and now all checks have passed. So let's just merge the pull request. Next we will configure a linter called flake8 that wraps PyFlakes, PyCodestale, and the Macabre complexity check into one tool. It tries to find common programming errors and bad practices by doing a static analysis to your code. This time I'm not going to do the configuration on the web page, but on my computer instead. Let's pull the changes from the server and create a new branch called flake8. Now that we are using black, we need to make sure that we are using compatible configuration for Flake 8. So in the black documentation, in the black code style section, there is an example configuration that we can use for Flake 8. So you can basically copy that. And Flake 8 is configured in one of three locations. There is the .flake8 file, the setup.cfg, or tox.ini. The setup.config file is a configuration file for setup tools. So if you're already using that, then it's a great place to put this configuration too. You can use the tox.ini file if you're using tox. Here I'm going to use the .flake8 file and paste in the configurations. I also changed the line length to 100 to match my previous configuration with black. Next, configure the workflow. Create a file called flake8.yml and configure the workflow in it. So we can do this without any special action by just invoking some commands on the command line. So name this workflow flake8 and trigger on pull request. Remember the trailing semicolon here. Then define the jobs. Call it flake8. This runs on, again, Ubuntu latest. Then we need to define 3 steps. In the first step, we need to check out the repository. So we use the uses actions check out at version 2. We also use actions and setup Python. And this is also version 2 with some configuration parameters. Here I am just setting this as an example, so you can configure the Python version. For example, to 3.x, which will be the latest version of Python 3, basically. But you could also make it run on 3.6, 7, 8, or so on. And the final step is to run flake8. So let's name this step to run flake8 and use the run keyword. We can use the pipe character to define a multi-line string. And the first thing that we need to do is to install flake8. So use the command python module pip install flake8, and then just use the command flake8 to run the check. And this is our workflow. Now to check that this actually works, let's change our project file to fail the check. This is also easy. We can add an unused import. So let's just import OS. And then commit this to the repository and publish to the remote. Let's open the pull request and see what happens. Now we have 3 checks running at the same time. And as you can see, the flake8 check has failed. So let's see the details. We get the error in the sample.py file, OS is imported but unused. So exactly as we expected. Let's remove the unused import and commit again. Now that all checks succeed again, we can merge this pull request. We can also configure actions to run unit tests. So let's create a new folder called tests. And inside it, let's create a file called test dummy. This will be a really simple unit test file just for demonstration purposes. So let's import unit test. And let's create the class which inherits from unit test.test case. And let's define a simple test that will surely fail. So test is false. And if we use self.assert false, but give it value true, then this test will never pass. We will also need to create an empty init.py file. This marks the tests directory as a Python module, which makes the unit test discovery work. So how do we set up unit tests with actions? Let's create a new file under the workflows. We'll call it unit test.yml. The name of this workflow is going to be run unit tests. We want to run it on every push. Then let's configure the jobs. It has one job to run the unit tests. It runs on Ubuntu latest with a, and this is a new one for you, with a strategy of matrix and Python version, which will be a list of 3.6, 3.7, 3.8. What we did here was to configure a build matrix. So we defined this variable Python version that we can reference within our action later, and it will let us run the unit tests with all these different Python versions that we configured here. So let's implement the actual steps. First, we need to check out the repository again. So we use the actions check out version 2. We also use the actions setup Python version 2 with some parameters. So with, again, define the Python version. But this time, instead of setting a specific version, we are going to use this variable that we defined for the build matrix, which we can reference by matrix.python version. And the last step is to run the unit tests. So let's give this name run unit tests. We use the run command to run the Python module unit test, which will run in the test discovery mode and find our tests. Note that because we don't currently use any external libraries, we don't need to install the requirements. But if you have external dependencies, then you need to remember to install them first. So you would add a new line to the configuration where you would install the dependencies. For example, Python module pip install -r requirements.txt. So if you had the dependencies in the requirements.txt file in your repository, this would make sure that they are installed before running the unit tests. But right now we don't need this, so I can remove these lines. Let's commit the code and see what happens. Actually, I'm on the wrong branch here, so Let's switch to the master branch. And let's create a new branch. And give the commit message. Let's create another pull request. So as you can see, the unit tests were already running when we opened this pull request. This is because the action is run on the push event. So they started to run before I even opened this PR. And you can see that the action has now been run 3 times. Once for 3.6, 3.7 and 3.8 Python versions. We can check the details and see what went wrong. Well, true is not false, so obviously this test fails on all Python versions. So now this works too. Now that we have some good status checks for our repository, we can configure branch protection rules. So if you go to the settings tab and branches, you can create a branch protection rule. So give the name of your main branch. So for example, main or master, whichever you happen to have. You can require pull request reviews before merging, but if you're mainly working on your own, then this doesn't make much sense. But the second option, require status checks to pass before merging, is a good one. Here you can choose which checks should pass before a pull request can be merged. So from this list, we want to have the black check for the code style, flake 8 for linting, and then the unit test actions. Notice that we don't want to have the labeling or the first interaction actions selected here. Then click create and give your password. Now the branch protection rule is in place. Let's go back to the pull request. As you can see, this button has now changed color to red. As an administrator, you are still allowed to merge this pull request even if the checks fail, but this can also be disabled. Let's quickly fix the test so that we can merge the PR. Just change the assertion to false and commit the change. The checks are now rerunning, and you can see that 5 of them are required. Now all unit tests have passed, and we just need to wait for the black check to finish. The pull request is now green, and we can merge it. That's it for today. Go create some issues to the repository if you'd like to see something added. Hopefully you found this video useful. Like it if you like it, and we'll see you on the next one.